Not very complicated. What do you call this thing here? A block, and it represents the system that you're going to be working on all semester. Each of you has a different aspect of a system. What do you suppose this represents?
What goes in? Faucet.
The input into the system. Now, it doesn't mean like water or air or anything like that. It means information. So the input into the system, in all of our systems this semester, is going to be percent input. So I'm going to do an experiment a little bit where I can choose the percent input, and it's going to be a constant. The system will respond in however way it does. Systems are like that. They're just like people. If I give you some sort of stimulus, you're going to respond, right? If I make a fist and pop you in the chin, you might respond by going like this, or you might respond with two fists back at me or something like that. I mean, this system, you're going to determine what the system does by observing this. So you're going to put in an input, and what's going to happen?
Result.
Output, which is the result. So that's not too complicated, am I right? Your name is Brett. Sarah. Anyway. All right, so I'm going to put an input function into the flow system that's a constant. This is all you do in week 1 and week 2. And I'm going to put my name here. Oh, I'm better than this. Put your name there. Then put the location. Guess where I am? EMCS 403. I want you to always put that location plus anything else you want, like home, library, friend's house, anything in the world you want to put as a location. But be sure to start with EMCS 403 and then anything else you want to. And then your email address, and I want you to use your UTC email, please, always. Mine's shorter than yours because they don't make me use that thing Google, right? So always put your UTC email address in there. That's just information about you. Now then, I want these parameters for the experiment. How long I want the experiment to run? Wow, flow is fast. Let's say 12.5 seconds, just for fun. And I want to run a constant input of, let's say, 50%. Did I tell you that the units of input were always going to be percent? There they are. And the length of the experiment is either going to be seconds or minutes, depending on which system you have. And I'm not going to mess with the valves. To tell the truth, on the flow system, the valves are not working right now. So it doesn't matter what you put down there. You can put down 7 million if you want to. And it's totally ignored. That's 700,000. Let's put another zero. Then I'm going to click Run Experiment. In the experiment, is now put in a queue, and it will run. Oh, it's already started. 50% was my input. That's over on this scale. Input values are the blue line, 50% input. Over here is the output in pounds per minute. 100% 100% finished, 12.5 seconds. This is the steady state flow output for 50% input. And you remember the purpose of our week 1 and week 2 experiment, as we get a steady state operating curve. To do that, you'll do this kind of experiment several times in order to find out when the input is 50, what is the output? And it's about, well, here's where you can use Excel. So they get an average and a standard deviation, because I guarantee you there are more than 29 data points there. You want to know how to make it easy? You click on that thing that says open text file in Excel. What's that say? Oh, I know that. So say yes. It's not really an Excel file, but we call it one. Don't ask me why. So here's the Excel file. Up here at the top is some stuff with information about the experiment. The date and time it ran, the name I put in, and here's location. Please don't use any profanity. Email address. System is flow, the experiment is constant. The length of the experiment is 12.5. Inputs 50%. Solenoid valves 7 million open, and that's ridiculous. But it doesn't matter on the flow. It matters on some other. And then here is a column of information. Oh, I didn't write that down here, do I? What happened? Okay, so time of the experiment, the input value and the output value. And remember, for the first little bit it was 0 input, so we go down in time and the input comes up and it looks like you have 340 423 data points, but you can't use all of them because some of them hadn't reached steady state. So you got over 29 data points that you can take the average and standard deviation and get one value, the output for this input. And you'll need several of those different inputs in order to get a steady state operating curve. So I'd suggest you divvy up your team. In fact, I'd ask you to do that. Let's go back here. Let's go back and look at these team assignments. And let's look at somebody. Okay, here is red. Those valve flows, that's useless. But I want the first person in red, Austin, to do a flow rate in the range of 31 to 35 pounds per minute. Second person, Benjamin, 35 to 39, and I left off something. Brandon will be next. Let's look at this one. This one's better. Aaron, 15 to 19. Alex, 19 to 23. Alexander, 23 to 27. Ashley, 27 to 31. Now, how are you going to get that? I ran an experiment, right, and had a certain output. Was it any of these? Was it in any of these ranges? What was the numbers? Anybody remember?
13 or 14.
Huh?
13 or 14 is below 15.
Okay, so it wasn't, it didn't satisfy any of these team members. So 50% was not what your customer was interested in. You have to get a higher percent so it'll run out than him. Questions?
Does that tell us our team, the experiment we do, or do we do all the same experiments?
No, what color are you in?
Blue. Because I see different ones there.
Okay, the first person on the team, it's a little hard to read this, Ethan, has, this is pressure with number 2 damper closed. Pressure is between 5 and 13 centimeters of water, I think the units are. Jeffrey has, his values are between 13 and 21, and Jerry's between 21 and 21. So you're actually going to get,
And that's for the spray booth pressure?
that's spray booth pressure. Yeah. Now, let me show you. Let me show you this thing. Let's do pressure for the time being. And I think your values were from about 10 to 30 centimeters of water. I think that ring a bell. So this will go from 0 up to 100. And one person in your team might get a few data points like this. The next person might get a few data points like this. The next person might get a few data points like this. Output pressure as a function of input pressure. These are called the steady state operating curve. Steady state operating curve. Now, I'm not saying they're all curved, they might be straight lines, but I'm just saying that's what we're looking for in the next 2 weeks experiment. I think I'll scan this and put it somewhere so you can see it. Now, this person can get the slope of their section. This person could get the slope of their section. This person could get the slope of their section. You suppose all these have the same slope? They might, or they might not. There you go. How accurate do you suppose I want the slope? 1 6-figure work, 2 might be a little bit better. Good question, good answer. So, you have between now and a week and a half from now to get this, these experiments done, analyzed, plotted, because when week 3 gets here, which is 2 weeks from today, certain of you will have reports due. Does that ring a bell? Let's go down here. Written report schedule. Week 3, these teams here have a report due that will be the steady state operating curve report. And week 4, different teams will have presentation. Fit in? No. Listen up. Stand up and ask your question. Ask your question. Stand up and state your name and your team name. Loud and clear so everybody.
Josh from Ivory.
Josh.
I have a problem I'd like to know. My question was, do we have to do a report every experiment?
No. Week 3, third member in each of these 4 groups does a report. Those are the only people. Just 4 people do a report in week 3. 4 people do a report in week 4. 4 people do a report in week 5. I thought we skipped a week, because the presentations we skipped a week. Okay. So, next week, free, no reports due. Week after that, these people have to. If your team has 4 in it, we'll have to figure out where to put the 4th person.
What would week 4's reports be
What?
What are week 4's reports just about, yeah, are they?
Good question. Stand up, state your name and your team name, and repeat that question in a loud and clear voice so everybody can hear and understand you.
My name's Ben Kegley with the Red Group. I asked, what would week 4's reports be over?
Excellent question. 1 clap for Ben Kegley, and 1 clap for the earlier question. You know why I have 1 clap? It saves energy. I mean, that applause and more than 1 clap is just a waste of time. This tells you an outline of what's in that report. But basically, every report builds on the preceding report and